Hi there, this is the Practice Chapter 6 test, and as always, I am the amazing Mr. Jansen. So away we go. If we take a look at this first one, the first thing we're looking for is the vertex. Remember, to find the vertex of this thing, we have to use this tiny little formula, the opposite of b over 2a. All right, and remember, that's also part of our quadratic formula. That's where it came from, because it's the opposite of b, so that's going to be a negative 4 over 2 times a, which for this one is a 1. Remember, it's a, b, c. All right, so that's a negative 4 over 2, which is a negative 2. So that's the x value for my vertex. That is a terrible looking 2. Let me try again. So now that I have the x value for my vertex, if I want the y value that goes with that x value, I just plug it in. So I plug the negative 2 in for x, and it's going to spit out a y value for me. So that's going to be a 4 minus 8 minus 12. That's a negative 4 minus 12, which is a negative 16. All right, be careful when you're plugging that in, especially with your signs. Now the axis of symmetry, remember the axis of symmetry is like the mirror for this thing. It's a vertical line, which means it's x equals. And the axis of symmetry always goes through the vertex, so it's the x equals the x value from the vertex, which is the negative 2. And that's it. All right. The y value, remember the y value is where we plug zeros in for x. And if you imagine this, if I plug a 0 in here and a 0 in here, all that's going to be left is this negative 12. Remember, that's our shortcut. The constant value is the y-intercept. The x-intercepts, this is the reverse of that. Remember, the y-intercept, you plug a 0 in for x. The x-intercept, you plug a 0 in for y. Well, this is our y value, so you're going to plug a 0 in right over here. So in other words, what we'll have is x squared plus 4x minus 12 equals 0. And I just have to solve this. Okay, I'm going to solve this for x. So to do that, I'm going to build a bridge. That's a negative 12. The two magic numbers that I need here are going to be a positive 6 and a negative 2. I can use my shortcut, so that's x plus 6 times x minus 2. And now I set each factor equal to 0. Let me scoot this guy down a little bit. Give myself some space. So I do x plus 6 equals 0. I do x minus 2 equals 0, and I solve each. This one I subtract the 6, so I get x equals a negative 6. Here I add the 2, so I get x equals 2, and that's it. All right, those are my two x-intercepts. And keep in mind as I'm writing these things, the negative 6 here, my bridge got in the way, and the positive 2, keep in mind that all of these mean separate points. Up here, the negative 12, that's really the ordered pair 0, negative 12. The first x-intercept, the negative 6, is really the ordered pair negative 6, 0. And the second one, that's 2, 0. Right? So when we talk about the intercepts, each intercept is its own separate ordered pair. So keep that in mind as we go to plot these things. And then the last piece, the maximum and minimum, when we look at the a value. Here, the a value is a positive 1. Since it's positive, that means this thing is going to open up, which puts my vertex at the bottom, which means that this is a minimum. All right, and that should be true when we go to graph this thing. If we look at the values we have. I've got a negative 16 in there, a negative 12, so I'm going to have to scale this differently. I'm going to go by 4, so I'm going to make this 4, 8, 12, negative 4, negative 8, negative 12. Same thing here, negative 4, negative 8, negative 12, so on and so forth. 4, 8, 12. You get the gist here. All right, now I plot these. Negative 2, negative 16. It's going to be down here. X equals negative 2. Again, that is a vertical line. It's a dotted line. Perhaps should have put my numbers on the other side. Let me try this again. Let me try again. Let me put my numbers over 4, 8, 12, 16, 20. Yeah, I needed to include more anyway. It's a negative 4. That's a 4. It's a negative 4, negative 8, negative 12. Just to clean this up a little bit. Now I'll plot this. There we go. So negative 2, negative 16 is right about there. Axis of symmetry, again, it's the vertical dotted line where x equals the negative 2. The y-intercept is 0, negative 12, which is right here. I can reflect that point, which would put another one right over here on the other side. Boy, that point got a little out of control, didn't it? There we go. Again, reflect that point. Axis of symmetry is a mirror. And then the negative 6, 0 is right here. The 2, 0 is right here. And again, those points are already reflections of one another. And I draw my graph. Okay? Easy enough? Of course it's easy enough, Mr. Jansen. Plotting points, drawing a curve. If I take a look at the next guy, again, I start the same way. The vertex, I'm going to use the opposite of b over 2a, so I'm going to do the opposite of b over 2a. So the opposite of b is going to be a positive 2 over 2 times a, which is a negative 1. So it's 2 over negative 2, which is a negative 1. That's the x value for my vertex. All right. To find the y value, I've got to plug that negative 1 back in. So I'm going to plug it in, so I've got negative x squared. And this is why I always use parentheses. See, it's x is in the negative 1. So it's a negative 1 squared minus 2 times a negative 1 plus 3. Now, order of operations, I do this piece right here first. Okay? The negative 1 squared, which gives me a positive 1. And then I tack on this negative sign that's out here. Be careful with those signs. And then here, the negative 2 times the negative 1 is a positive 2, so that's plus 2. And then plus 3 tags along for the ride. So that's going to be 1 plus 3, which is 4. Okay? Lots of places to make little sign errors here, so just be careful. Axis symmetry, again, is a vertical line, so it's x equals. Got to have the x equals. Can't just put a number down. X equals, and so it's the x value from the vertex. It's negative 1. The y-intercept, again, is when x equals 0. If I plugged zeros in for x's, I'd just be left with the constant term, which is the 3. Okay, and again, that's the ordered pair 0, 3. If you want to think of it as an ordered pair, it might help you when we're graphing. The x-intercepts is when y equals 0, so if I plug a 0 in over here for y, I'm going to have negative x squared minus 2x plus 3 equals 0. And you see the issue with this one is if I go ahead and build my bridge right now and get a negative 3, I can come up with the two missing numbers, the negative 3 and the 1, but the problem is I can't use my shortcut because of this negative that's out here. So if I want to use my shortcut, I've got to do something before I build this bridge. And what I'm going to do is I'm going to divide each side by negative 1. Because I have an equation, I can do that. I can divide each side by the same thing. That's going to give me x squared plus 2x minus 3 equals 0. Now if I build the bridge, it still gives me a negative 3, but my two magic numbers that add up to the middle number are going to be a positive 3 and a negative 1. And now I can use my shortcut. It's x plus 3 times x minus 1. And now I set each factor equal to 0. So the x plus 3 equals 0. The x minus 1 equals 0. I subtract the 3 from each side here and find out that x equals a negative 3. Here I add the 1 to each side and find out that the x equals a positive 1. And those are my two x-intercepts. And again, keep in mind that they mean two separate things. A negative 3, 0, and a positive 1, 0. It's two separate ordered pairs. All right? And again, looking back at this guy, the a value was a negative, which means this is going to open down. It's going to be a sad parabola, which means my vertex is up here at the top. So it's a maximum. Maximum. And we'll see that when I go to graph it. All right? So taking a look at the graph, it looks like I don't have to scale this any differently, so I'm going to go by 1. So you don't have to write it if you're going by 1s. Negative 1, 4 is going to be right here. Axis symmetry is x equals a negative 1, which again is the vertical line. It's a dotted line that goes through the vertex right there at negative 1. That's our mirror. The y-intercept is 0, 3, which is right here. I can reflect that point through the axis symmetry. The x-intercept negative 3, 0 is back here. Positive 1, 0 is right here. And if you notice, those points are even reflections of one another. Now I have enough information to graph. So I draw my parabola, and if we look at this parabola, it does have a maximum. It opens down, the vertex is at the top, and that's it.